Hey everybody, and welcome to another episode of AZ Bytes. I'm John Lunn, and today we're going to dive into one of the hottest topics in cybersecurity. Did you know that over 80% of breaches actually start with that stolen password? And it seems like every other week we're hearing about another major hack, and it often boils down to an attacker simply logging in with somebody else's credentials right. So that old castle and moat approach that we are very used to in security, the big walls and trust everybody that's inside, is really showing its age in this world of cloud computing and remote working. So how do we protect our data when the perimeter defenders can't really keep the bad guys out? That's exactly what we're here to talk about today. And I'm joined by Ibrahim Mukherjee, a cybersecurity expert and one of the minds behind a new product called SafePulse. So we're going to explore how modern security is moving, from just keeping intruders out to continuously verifying who is already inside. So we're going to discuss, trust should never be taken for granted, and how technologies like the zero trust network access, continuous biometric authentication, and things like passwordless logins are really come together in SafePulse to create a bit of a living security system that could change the game. So whether you're here as a business leader, worried about breaches, or just somebody curious about the future of cybersecurity, stick around. This conversation hopefully is going to be for you. So welcome, Ibrahim. Good to see you. How are you?
I'm good, John. Really nice to be on your podcast. Real pleasure. And yeah, looking forward to sort of discussing more about SafePulse and cybersecurity in general.
Yeah, absolutely. Look, I tell you what, let's crack straight on into it then. So let's start with that big picture piece then. We hear about these cyber breaches all the time. From your perspective, Ibrahim, what are the biggest challenges that we see with the traditional approach to cybersecurity today? And why are those old perimeter-based defenses really not living up to standards today?
Yeah, I think this is really good. And I think you touched on a lot of the key points in your introduction to this video. So IBM research shows 95% of data breaches are due to unintended human factors. And there's a French cybersecurity firm that have come out and said that cybercrime is worth 10.2 trillion. So that is the third largest economy in the world. That's bigger than everything apart from US and China. So I think just for people viewing this, even cybersecurity professionals like me and you, I'm a qualified CISO from the EC Council, currently doing CISSP, but we know how critical the problem is, but just to put a kind of scale of the problem. So the real reason why it's not working is that the traditional systems have been built in a very static way, okay? And they've been built in a cloud-first way. So if you look at most of the current ecosystem right now, the processing is done on the cloud, and most of it is a session or an event-based security measure. So if you have your password, it's a session that you're logging into. If you have your MFA, that is triggered by a particular event, okay? So if you think of security as a continuum from a session, okay, to another session, then effectively right now we're covering the beginning of the session, we're covering events in the middle, and then we're covering the end of the session, okay? What happens in the middle is basically where the breaches are going to happen more and more in the cybersecurity industry, right? So we are saying we need a continuous authentication platform. So not something where it's, one time and then another one, and then one at the end, but actually something that continuously covers. So there's a security envelope that is invisible, that is constantly on throughout a person working on a computer, which is sort of the main thing that we are targeting. So this is why current systems are broken, because they're based on either an event or a session, and the paradigm really needs to move to something which is continuous. So that is always on.
I guess just picking up on that stat about 80% of security breaches being around stolen login credentials.
Yeah.
I guess that's the point, right? Passwords are weak, I guess, Ibrahim,
Yeah.
right?
Yeah, so I haven't done a huge amount of work on the dark web, but for a while I was doing some DNS blocking work with Quad9 as part of my open source foundation, THAM. That's a Swiss government nonprofit, and we were just looking at specifically DNS, malicious DNS in the blockchain space. And when we came up with the initial list, Quad9 said we actually don't have any of these. So the dark web is obviously bigger than the surface internet. It's kind of like the tip of the iceberg that we're using, and then there's a dark web that's far vast and far more complex than any of us would ever understand. And what's going to happen is that every time there is a breach, all of these passwords, all of these events, even passkeys, different systems will end up on the dark web for sale for $1 or $2 or 20 cents, whatever it is for 100 passwords. And the thing is, once it's out there, which almost everybody's credentials are, really, it's basically just finding one chink in the armor. And the chinks will come where the interlocking parts, where two different systems interface with each other, leave a little gap in the middle. And that's the gap that hackers are traditionally always sniffing for and looking to exploit. And whenever we have different companies with different systems, be it a Microsoft system or a Google or a Palo Alto Networks or a Fortinet, you will always find these gaps between things. APIs don't always work with each other well. TLS and encryption always doesn't work. Somebody's encrypted at rest, somebody's encrypted during transit. There's some small pocket and somebody's going to exploit that.
Yeah,
and this is effectively what's going to happen.
No, that makes sense. So I guess, we framed the problem that we've seen today in cybersecurity. Let's delve into a little bit. I mentioned in the intro there around kind of that zero trust network access.
Yeah.
You spoke a little bit about continuous authentication, and then obviously the whole password thing. Can we break those three elements down? So kick us off in terms of zero trust network access. For those people that aren't really familiar, can you give us a very succinct explanation of what that actually means?
So zero trust network access, the way I see it, and of course there is different sort of commercial and academic definitions. Zero trust network access is basically, you don't, by default, you assume somebody is not verified. Okay, so that's the paradigm that we're working in. So by default, you don't start with the assumption, I know this person, so therefore, this person is allowed in. Zero trust network access basically means you start with the default position that this person is not verified unless they're verified. And this is actually something that, for example, we are going to see in consumer apps that are happening more and more. So whoever is using an iPhone, every time you pay, I live in London, I use the tube. Every time I pay on the tube or even in a corner shop for a bottle of Coke, I have to do Face ID, even for a £2 transaction. So it's my phone, and Apple should be smart enough to know that I'm using that phone. They could have used many other tools to figure out I'm holding the phone, maybe a fingerprint sensor on the screen, but they will still do a face authentication. So by default, it is assuming that I don't have access to the network, which is my network, my iCloud drive, my files on my phone, without me being authenticated every single time. So that's what zero trust network access basically means.
Yeah, that makes a lot of sense. So moving on then to the next kind of piece of the puzzle. So continuous authentication. I mean, to me, it's a bit of an intriguing concept. Traditionally, once you're logged in, like you say, the system assumes that you're that right person that you just described there. But what is this continuous authentication, and how does it change things? Can you describe it? You mentioned biometric authentication. Can you describe a little bit of how you see that working?
Absolutely. So actually, kernels of this is popping up everywhere. So, as much as I would like to imagine I'm the inventor of this technology and this is completely brand new, but it's not always. There's always parallels in the tech space. Other people are doing similar things. So let's take an example, which is real world, so people can actually visualize it. So imagine you're an employee working in a nuclear facility. You've got your badge, your ID, you're tapping in and you're going into the facility. At that point, the current cybersecurity kind of landscape or security landscape in general would assume that person is now verified. If I had, let's say, an iPhone that I was allowed to take into the facility, and I'm holding that iPhone or I'm putting it in my pocket, every time I walk, the iPhone can measure my gait and say it's uniquely mine. Or every time I hold it, it can look at my fingerprint and say it's uniquely me. So effectively, it means while I'm walking within the facility, doing my job at a very sensitive facility, every point of contact with a particular device is a touch point to authenticate, hey, it's still me, actually. It's not somebody else now, right? So that is the premise of continuous authentication. Now, bring it back from a physical security space into a cyberspace. Every time I log into an enterprise company laptop, if you're working for Cisco, for Microsoft, for Google, for whichever big company, you've walked into the facility, you've opened your corporate laptop, you've logged in, you've started working. The assumption is it's now going to be you from 9 o'clock till 5 o'clock. And what we're saying is no. Every time you type, every time you move your mouse, every time you effectively interact with the computer, which in computer science is human-computer interaction, right? That is a touch point, and that is data that is right now not being tapped into by any major player, and we're going to use that to authenticate you. So that is what continuous authentication and biometric authentication means. What are the other parallels? Face ID, Apple's Face ID, very popular one. We're not using face because it's very intrusive. And we don't need to, because all we need to do is what is currently being used. A programmer will type, somebody using Excel or PowerPoint will type or use the mouse. That's enough for us. So we're not being intrusive. We're using what I would normally term as data exhaust, data that is already there that nobody's currently using, right? So that's another part of it. And the third part of it, what are the parallels? So in China, we know there's gate detection. So let's say you're wearing a COVID mask, you've got your hoodie on, and you've jaywalked in China. Just by your gait, they can tell it's you, because everybody's gait is unique to themselves. So the micro movement between your shoulders, between your neck, how one foot falls in front of the other is unique to you. It's not just your fingerprint. Every part of a human being will be unique to them. So everybody's eye color will be slightly different. Everybody's hair color will be slightly different. Everybody's gait will be slightly different. There are so many ways of identifying somebody as uniquely human. And effectively what we're saying, we're just going to take the existing data that already exists, that nobody's right now using, and just provide an inference engine on top and verify it's you.
I mean, that the word I used there was intriguing, and that's really great to hear, like how you described that. There's just so many different ways that you can identify people. So look, we've talked about zero trust. We talked about potentially continuous authentication using biometric markers.
Yeah.
The third piece of the puzzle, as I understand it, and I know we had a chat about this before we did this recording, but that whole password thing, we spoke about FIDO and passwordless authentication.
Yeah.
Is that the third piece of the puzzle here?
Yeah, so the way I see it, as somebody who's working actively in the cybersecurity space is, so I see it as almost a consumer problem, right? So the way I see it is saying, okay, anytime a user needs to take an additional step while they're working is friction. And a good consumer company will always try and reduce that friction, right? So if you think about, the great sort of tech giants like Steve Jobs, they will spend excruciating amounts of detail into making sure there's as little friction designing the user interface so it's so intuitive a grandmother can use it, to try and reduce that friction. Anytime you have to use a password, an MFA, a passkey, unless your device makes that automatic and seamless to the point you don't even notice it's there, it is friction. Because imagine I'm waking up in the morning, I'm going into the office, I have a really important presentation to do for 10 o'clock. Last thing I want to do is my password, my MFA, but the MFA is right now not working, or the passkey is not working, or if you've got your email, you have to save your passkey somewhere. Is it a hardware encrypted wallet, where a hard drive or something where I need to save those passwords or passkeys for my Gmail login? It is so much headache. It's so much admin headache because there's so many different moving parts and different systems all trying to communicate to just do something very simple, which is authenticate you, that it creates the consumers a huge amount of headache, time, lost productivity. And we are saying, take all of that out. Biometrics is enough. There are other companies that have proven that biometrics is enough, like Apple has done with Face ID. And it is time to just, and even for laptops, you've got your fingerprint, but they are session and event based. And we can just use, the biometrics that you currently have to authenticate you based on your typing pattern. So imagine in the racist world, you go into your workplace, you literally just open your laptop and maybe you enter your password, and I would try and even cut that out, not even enter your password. You just start typing, and straight away within 5 seconds, it knows it's you. The inference engine is local. It's not moving any data to the cloud. And off you go, you start working. You don't even know there are any passwords or MFAs or passkeys. Even if that system needs to be integrated into SafePulse, it can all be done back-end without the person even knowing is there.
I mean, Ibrahim, let's talk a little bit about that on that topic now. Let's break into that, that whole thing of what is SafePulse. And I think you started to kind of break into it. So we've got all the groundwork laid. Let's talk about SafePulse now. So what is it exactly, and what how is it trying to solve those problems that we've talked about for organizations?
Yeah, so SafePulse is if you wanted to talk about it in very simple terms, we do provide a user interface like Microsoft Sentinel, but if you even cut that out, you can think of it as an invisible daemon app. Okay, all it does, it sits in the background. It looks at your mouse movements, your typing patterns, and some other proprietary indicators of how you interact with the computer, which because of intellectual property we can't go into. And it will authenticate you on a continuous basis. So every touch point, every time you touch the laptop and start using it, that is a point of biometric authentication. We use a 30-second window. So we authenticate every 30 seconds. Right, so it is still event, but the events are so much more granular than the normal kind of events, once every 2 hours or once every something breaks, and it is invisible and behind the scenes, so user does not even need to know that it exists, and it's working.
I
It's
mean, I
just
was
working for them.
I was going to ask that. So, I mean, help me understand what really makes SafePulse different in its approach from traditional security products that are out in the market today.
Yeah, so I think the first thing is the use of biometrics and continuous authentication. There are parallels, but nobody's gone to the extent and detail that we have. That's number one. The number two, it is continuous, so it is always on. And the third one, which we also touched on, it is very low friction, which basically means our goal is eventually to cut out any form of users having to actively authenticate themselves, either through a password or a passkey or an MFA. So basically cut out the user friction that currently exists for security. Because from a user perspective, if you put yourself in the shoes of a user, this is inconvenience. What we consider security and very critical and really good stuff that we are doing for a user is just like, oh my God, here goes my MFA again. Here goes my password.
Sure.
Here's another ping. Because at the end of the day, that's not a core part of my job. My core part of my job as an employee is to do a presentation, to do an Excel, to write some code. It's not entering passwords or MFAs. This is an inconvenience for me. So why do I want to do this? The less I can do and get away with it, the better it is for me. And that's effectively what we're trying to enable.
No, that's amazing, Ibrahim. So I guess we're at the stage now of saying, look, we've seen the problem. We understand a little bit around what SafePulse is actually doing. For business leaders and people watching this video now who are really concerned about kind of improving their cybersecurity,
Yeah.
what's the first step? How can companies begin to move forward with this kind of adaptive continuous security model and SafePulse? Are there any quick wins? How should they approach that, Ibrahim?
Yeah, so our website is www.erases.co.uk. That's ERA Systems. You can think of it, ERA, ERASYS, erases.co.uk, all one word. And you go their website, you can sign up for a free trial as a consumer, which we're rolling out as an enterprise. You basically just fill in our form, and our support team and our sales team will get back to you. We are part of the Intel Partner Alliance. So because it's a local inference model, so we don't actually process in the cloud, we process locally. We've made a lot of effort, even though it's a PyTorch model, to shrink it down. The global inference was done on PyTorch across general biometrics, but the local inference, which is specific to the user, is done locally. So data is not being transferred to the cloud. And we've specifically made sure of that, to ensure speed, but also to ensure privacy and to maintain security policies for enterprise applications. You simply as an enterprise, roll it out across your organization. And then if there is a security incident or an event, there's a SOC dashboard that plays nice with all the other cybersecurity tools. So we built an API, it works with Palo Alto Networks, it works with Microsoft Stack, Google Stack, Fortinet. We've just integrated Wazoo, which is the open source alternative to Microsoft Sentinel. And so SOC teams will get an update. It is quite a complex processing layer. So there's 4 stages. There's an initial stage, which is looking at attack patterns, but only from a biometrics human risk perspective, which nullifies both insider risk and very obvious bot attacks and sort of people trying to use, let's say, a bash shell to log into somebody's system and try and use it. Then there's statistical verifier, which verifies it's the human, but only on a statistical level using standard algorithms. Then there is a machine learning verification layer, which uses a PyTorch model as well as a SVM support vector machines model working concurrently. And then finally, we have a decision engine, which takes the first 3 layers and makes a decision. Okay, and it may be a hard no, a soft no, or a yes. And it provides a confidence level. And the reason we do it is because we want to reduce the false positive rate to below the industry standard, which we've been able to do. The industry standard is 3% for false positives. We've right now pushed it down to 2.3%, and we're trying to push it down even further. And that's why we need to do all this elaborate calculations locally to be able to reduce the false positive rate. However, it is still blazingly fast.
That's amazing. Some really great detail by here. Erasis.co.uk. Check that out. We'll put a link in the video description below. There's no doubt more information that people can read on there. And you mentioned a free trial that they can sign up for, right?
Absolutely, absolutely. So we have 2 products right now. White Matter, which again uses your typing to tell you whether you're stressed or not, and you can look more into it and help you follow occupational health guidelines. So every hour, get up from your seat. Every 20 minutes, look away from your screen. These are all occupational health guidelines. ETH Zurich have just published some research that typing is a better predictor of stress than heart rate. So this is more accurate than your Apple Watch, and you don't have to wear an Apple Watch. We can just tell you based on how you type. So that's a free trial as well. It's called White Matter. And then we have SafePulse, and Erases is a biometrics company. So all our work is related to biometrics, and these are the two products. They're both available for free trial.
That's amazing. Look, Ibrahim, thank you so much for sharing your insights and really introducing us to SafePulse. Before we wrap up, is there anything else you want to call out? I mean, we've got through a hell of a lot there in the last sort of 15, 20 minutes, but that sounds great.
Yeah, I think I'm always sort of happy to hear people's opinions. So, you can use your form on the website if you have any opinions, any comments. If you're a cybersecurity leader, if you just want to connect with me, you're more than happy to just drop me an email at ibrahim.mukherjee@erases.co.uk. And I think there is really good work happening in the cybersecurity industry. I think cybersecurity professionals, everybody realizes they're working overtime, many times SOC teams, they're on edge, they're on call all the time, but people are still doing incredible work, not just Erases, but I think all the companies and all cybersecurity professionals. So I'm really happy and proud to be part of this cybersecurity ecosystem, as being able to interact with you and other like-minded people in the cybersecurity ecosystem. So yeah, I think everybody doing a great job, and keep up the work. And I look forward to meeting more of you and interacting with you in the future.
100%. Look, it's been fantastic to speak to you, Ibrahim. And it really is fascinating to see how the cybersecurity landscape is really evolving at the minute. So,
yeah.
Look, thank you to all of viewers for joining us on this episode of AZ Bytes. We hope that you've learned something new about the future of security and really how to keep your organization safe from those emerging threats.
Sure.
If you found this discussion helpful, be sure to like, share, subscribe, get in contact with Ibrahim, share your insights below. Really want to hear from you. And if you are ready to strengthen your security, don't wait. As Ibrahim said, start exploring, how these concepts like zero trust and this continuous authentication can really work for your organization. And obviously check out SafePulse and go and learn a little bit more. But Ibrahim, it's been a pleasure. Thanks so much for joining me today. And thank you to everybody for watching. See you on the next one.
Thank you. Thank you very much. Have a great rest of your day.
Bye for now.